So imagine we have bunch of fruits like this and we need to group the fruits into similar ones. So what will we do? We will first place one of these into certain points like this, and then what will we do? We will put the similar ones by near of these points, isn't it? We will place all bananas together. We can see it with our eyes, and we know that these are the ones that look similar, so these should sit together, isn't it? So similarly we will pick one by one and place them together. We'll put this with the apples. Now we have easily made it into three groups. So this is exactly what k-means clustering does. It calculates the similarities and group the data points together into different clusters. Let's say we have this dataset and we need to find different groups from this dataset. We want to divide this dataset into different clusters or groups. So by looking at it, we can divide this into three groups. We can clearly see this difference between these three groups here. There is a considerable amount of distance between these three groups. But how can a computer do the same? That's where we can use algorithms like k-means clustering. It is used to cluster a dataset into a certain number of groups. So the first step is choosing the k value. So the k value in k-means means the number of clusters that we need. So let's say we choose 3 here. Choosing the k value is another topic that we will discuss at the end of this video. But let's say for an example, we have chosen 3 as the k value. So we need 3 clusters. So second step is the k-means clustering algorithm assigns 3 centroids randomly. So it will assign 3 points as the center of 3 clusters randomly. And then it will calculate the distance of all the points from these 3 centroid points. And step 3, it will assign these data points to the centroids from which these data points has the least distance. So in step 2, we have calculated the distance between the data points to all the 3 centroids. As we can see, this data point has the least distance from the red centroid than the blue or the green centroid. So this data point will be assigned to red, and this data point has the least distance from blue, so it will be assigned to blue. And all these data points have least distance from this point centroid green, so it will be all be assigned to green. So that's step 3. And in step 4, it will calculate the mean of all these clusters. Now we have received 3 clusters here, isn't it? So in step 4, it will calculate the mean of these clusters. So the mean of this cluster will come somewhere around here, and the mean of this cluster will be here, and the mean of this cluster will be here. And now it will assign these mean values as the new centroids of these 3 clusters. So we have 3 new cluster centroids, and then again it will calculate the distance between these data points and these centroids. So it will calculate the distance of this point to this centroid and this centroid, and we can see this data point is closest to this centroid, so it will be assigned again to this cluster, and it will do the same for all the 3 clusters, all the 3 data points. And it has again reached to the same 3 clusters. There is no change between the 3 clusters. And as the final step, when the algorithm sees that there is no change in the centroid values, it will stop that. And then as step 6, it will calculate the variance. So it will calculate the variance between all the 3 clusters. And as we can see that the variance is pretty high here, isn't it? So if the variance that is calculated by the algorithm is much higher than the threshold value, what it will do is that it will start from again randomly assign the centroids. So it will start from which step? It will start from step 2. It will again assign 3 centroids randomly, and then it will do all the steps again. It will do all the steps from step 2 to step 6 again. It will calculate the distance between these centroids and the data points. So as we can see, this point is closer to red, this point is also closer to red, this point is also closer to red, so it will all be assigned to the red centroid. It will all be the red group, and this data point, these two data points are closer to the blue ones, so it will be assigned to the blue centroid. And these data points are closer to green, so it will be assigned to the green centroid. So as we can see, it will again recalculate the centroid by taking the mean of each clusters. So the mean of this cluster, the red cluster, will be somewhere here, and the mean of blue cluster will be somewhere here, and the green one will be here. And now we have 3 new centroids for the 3 clusters. Now again it will calculate the distance between the data points, all the data points and this centroid, these 3 centroids. And we can see that this red point is now no longer closer to the red cluster. It is more closer to the blue cluster, isn't it? The new centroid for the blue is much more closer to the this red point than the red centroid, the red cluster centroid. So this will be assigned to blue. So you can see here it is assigned to blue here, and the remaining clusters are also again assigned to respective centroids by calculating the distance between them. So we can see that there is a change, there is a much better change here, and it will again continue and calculate the mean again. So the mean will shift to here, and it will again calculate the distance between the data points and the clusters, and it will assign to the respective clusters to which it has least distance. And after that it will again calculate the variance. Now we can see that the variance has become much better. The variance has reduced considerably. But the algorithm will not stop here, because it cannot see that we have received perfect 3 clusters. So it will again go on, starting from step 2 again, to reassign the centroid. It will again calculate the distance. It will assign to the different 3 clusters. It will calculate the mean, change centroid again, calculate the distance again, and it will again calculate the variance. And the variance could be higher or lower or anything. And finally, after doing all these calculations, plus it will come to a point where there is not much change in the variance, and it will pick up the best cluster with the least variance. So that's how the clustering, k-means clustering algorithm works. So now we have doubt. We will go back to the first step. I told you that we have taken k as 3, but we cannot always know how many clusters we need. Some cases we know that we need certain number of clusters, but not always. So how do we choose the correct k value? And for that, what we can do, we can maybe think about like this, isn't it? We can maybe think that we will choose different k values, like k equal to, starting from k equal to 1 to let's say a number like 30, k equal to 30. We will calculate the variance of all the clusters of k values for different k values, and we will pick the k value with the least variance. We can say that, but that is a really time consuming task. So another thing we can do is we can calculate something called as a Silhouttes coefficient. So that's what we are going to discuss next. So the Silhouttes score for a single data point is calculated using the following formula. S of I is equal to B of I minus A of I divided by the max of A of I and B of I. Sorry, this is actually B of I. I have mistakenly put as B of A. So S of I is the Silhouttes score for the ith data point, and A of I is the average distance from the ith data point to the other data points in the same cluster, also known as intra-cluster distance. So A of I will calculate the distance of a point within its same cluster to all the other points, intra-cluster distance of ith point. B of I is the average distance from the ith data point to the data points in its nearest cluster that the ith point is not part of, or also known as inter-cluster distance. So in our previous example, the cluster that we have made looks like this. So let us calculate the A of I and B of I for this. So let's say we are going to calculate the Silhouttes score for the first point. So I will be 1. So A of 1 is calculated as the average of all the distance from this first point to all the other points in the same cluster. So we will calculate the distance of first point to all the other red points in the red cluster. These 3 are the distances, and we will take the average of that, and that will be A of 1. Similarly, B of 1 will be the distance of the first point to all the other points in the nearest cluster, which is the blue cluster, and it has these 4 points. So it will calculate these 4 distances and take the average of these 4 distances, and that will be B of 1. So we have now got B of 1 and A of 1. So the idea here, I hope you understand the idea here. The idea here is to get a maximum value for S of I. Also we know that S of I can only range between -1 and 1. So for S of I to have a value that is close to 1, this equation needs to be positive and close to 1. For that to happen, B of I must be really large and A of I must be really small. Only then this numerator and denominator will give us a value that is close to 1. So what that means is that intercluster distance must be small and intra-cluster distance must be large. So that means the cluster should be as far away as possible. Means the clusters should have a really clearly defined boundaries. Means the cluster should be as closest together. The data points should be as closest together to the same cluster, but must be as far away as possible from the other clusters. We must be able to differentiate these clusters very clearly. That's what this means. So if that is, if we can clearly differentiate these clusters, that means the Silhouette score will be high for this. So that's what the Silhouette score calculates. If it calculates that, if we can clearly differentiate these clusters, if there is a clear distance between these clusters. So this is the same point I have said before. AFI must be as small as possible and VFI must be large as possible. In ideal case, A of I is 0 and B of I is infinity. That won't happen. Okay. Anyway, so it means that there must be a clear separation between clusters. Okay. So that's the S of I for first point or 1 point or the ith point. So in order to calculate the whole Silhouette score for the whole clusters for the given k value, it is calculated as the average of all the Silhouette's point for all the points in the dataset. So there are n points in the dataset. So we will calculate the Silhouette score for all the n points and we will take the average of that. So that will be the Silhouette score for our clustering for the particular k value that we have given. So what we will do is that we will do this Silhouette score calculation for all the k values starting from k equal to 1 to a certain point, and we will see which Silhouette score is the highest, and we will pick the k value who has provided us with the highest Silhouette score. So that's how we find out the best k value given a problem where we have not given the initial, we are not told how many clusters we need. In that case, we will calculate the Silhouette score for all the different k values and we will pick the k value with the highest Silhouette score. Also, another but less efficient way to calculate the best k value is by using the elbow plot. So what this does is that it plots all the variance values for all different k values. We can see here the k value range from 1 to 10, and it has plotted all the distortion means the variance in the dataset. We have seen how we can check for the variance, and it will plot all the variance values against all the k values, and it will check for an elbow here. So you can see that it is a clear elbow here, isn't it? Because till then it has been dropping, the distortion has been dropping heavily, and after this particular elbow, the drop hasn't been that often, isn't it? The drop has reduced till here. It has been dropping really heavily, but after this point, I don't know if you can see this, but after the k value 4, the drop in distortion has reduced. So we will pick 4 as the appropriate k value. You might be wondering why we can go with this, because it seems much more easier, isn't it? But even though it seems much more easier, it's a really computationally heavy task. Okay, so that's why we are going with the Silhouette's method, and also the Silhouette's method is much more efficient. So now let's do a code walkthrough for k-means clustering. So let us first import all the necessary libraries: NumPy, Matplotlib for plotting the clusters, and k-means clustering algorithm from scikit-learn. Make blobs is a function that we use to make synthetic data for clustering algorithms. So blobs means clusters. Okay, so it will create us clusters. And Silhouette score, we have seen before that we need Silhouette score to get the best k value for k-means clustering. And let us create the synthetic data. So this this underscore here will represent the labels. We don't need it, so we are just putting it as underscore. Otherwise, you can mention here as y. So we only need the x values. Okay, we only need the features. So we are passing in to make blobs 300. We are saying that we need 300 samples. It means 300 data points and 4 clusters. Random state equal to 42 because whoever is typing in this code, I need them to get the same result as me. So let us explore the dataset X. You can see here the dataset X is X contains data like coordinates, isn't it? These are all coordinates, X value and Y value. These are all coordinates. But looking at this, we cannot understand anything. We cannot see any clusters or anything here. So we are going to plot it. So we will plot the X values and Y values as a scatter plot. X is equal to 50 means the like the size of the points, and blue is the color and black is the edge color. So we can clearly see here that there are 4 clusters, isn't it? Yes, the human eye can detect these clusters, but the computers cannot know it. So for that, we are going to do the k-means clustering. So first, as we have mentioned in the previous section, we need to get the best k value, isn't it? Yes, by looking at this, we know that we need we need 4 clusters. We need 4 as the k value. But there are scenarios where we don't know. So we are going to calculate the best k value using the Silhouttes score method. So we write a function find optimal k. We'll pass in the data and max k. Max k represent till how much k value we need to check. So max k can be 10 or 20 or 30. But for now, I think we have gone with 10. Yeah, we have gone with 10. So we'll pass in the data and max k value. And inside the function, we have this Silhouttes score array, which will hold all the Silhouttes score for all different k values. And we'll run a loop for all the k values, and we will fit the data with k-means clustering algorithm with the particular k value ranging from 2 to max k, and we will find labels for all the k values, and we will calculate Silhouttes score for that particular k value and the labels that you received for that. Passing in the data and labels for the particular k value, we will calculate the Silhouttes score, and we will append that Silhouttes score to the Silhouttes score array. And finally, after this loop is finished, we will get Silhouttes score. We will get in the Silhouttes score array all the Silhouttes score for different k values ranging from 2 to max k. Then we will plot it, because we cannot understand it by we can understand it by looking at it, but it is better to plot it. So we'll plot it with x axis being the range of k values and y axis being the Silhouttes scores. So and then we will calculate the optimal k value by using the numpy array function argmax. So argmax will return us the argument or the index of the maximum score inside this array. So this optimal k will hold the index of the maximum Silhouttes score, and we are adding a 2 to this because we have given here that the range starts from 2, isn't it? The range is from 2 to max k. So if you are purely going by the index of this highest Silhouttes score, it will be 2 less than the actual k value, isn't it? Because the range starts from 2, but the index starts from 0. So we are adding a 2 to this, so we get the correct k value for the optimal or for the best Silhouttes score. So that's the function. Now we are calling the function here by passing in 10 as the max k value and x as the data, and we have received the optimal k value, and we are printing that here, and we are also plotting it here. So let us look at the plot. So from this plot, I'll reduce the size. From this plot, we can understand that these are the different k values starting from 2 to 10, and these are the Silhouttes score. At 2, the Silhouttes score was around 0.6. At 3, it has improved, but at 4, it has touched its peak. So after 4, from 5, 6, and 7 onwards, it is going down, isn't it? Silhouttes score is going down. So we will pick 4 as the best k value, and also we have calculated that by using the numpy function here, isn't it? We already know it is 4, but also by looking at this, we can pick 4 as the k value, 4 as the best k value. And by using the optimal k value, we will again model our algorithm. We will model k-means algorithm by passing in the n clusters as 4 and random state as 42, and we will fit this model with our dataset again. And now we will get the best cluster labels. We will get the best clusters, and so these labels will contain the centroids. Okay, centroid values, centroid points, xy coordinate centroids for all the 4 clusters. So to see that, we'll plot it again. We'll plot a scatter plot with the x-axis being the x values and the y-axis being the y coordinates or the y values, and C is equal to cluster level. So C will be the midpoint, okay, the midpoints of all the clusters. And yeah, here we can see that our algorithm has been able to identify all 4 clusters differently, and it has marked the centers. So that's how k-means clustering algorithm works, and that's how we can find the best k value for our clustering algorithm. So one thing I will say is that do not go for the Silhouttes method when we know that our dataset only will be having 4 clusters, okay? Because by looking at this data, you don't need to calculate the Silhouette score, do we? No, we know that there are 4 clusters only by plotting this, isn't it? So this method is useful when it cannot be plotted on a 2D plot like this, okay? There will be instances where we'll be having a 4 or 5 or 6 dimensional data. Dimensions means the number of features or the number of columns, okay? There will be instances where there will be multiple columns. For that we cannot plot it and see it, isn't it? So that's where Silhouette score actually shines, okay? So yeah, so that's all about this video. I have explained k-means clustering clearly. I have shown you how to get the best k value, and also I have shown it in code example. This code will be shared in the description. So thanks for watching. I hope you have enjoyed this video, and kindly like and subscribe to our YouTube channel if you haven't already, and share this video with your friends. Until next time, happy coding.